The notes for AP Calculus on the topic of solving absolute value inequalities. And usually the first thing people remember about absolute value signs is it changes negative numbers to become positive numbers. But the reason why it does that is what it represents is absolute value is the distance away from zero in the middle. And distance is never negative, it's always a positive number. So you can't say that I ran negative 5 miles. Even if I ran 5 miles running backwards, I still ran 5 miles, not negative 5 miles. So that's why absolute value is always positive. So let's look at the examples we've got here. I'm going to follow the steps I've written up here on the top of your notes. So it says solve the following inequalities and then graph the solution. So first thing you want to do is isolate the absolute value by getting it by itself on one side of the inequality. This first one, it's already isolated. There's nothing else on the left side of the inequality. And then what you do after that is you think about on your number line here, less than or equal to 1. So the distance away from 0, here's 0, is less than or equal to 1. So it can be 1 either direction. So it can be equal 1. So it can be 1 this direction, 1 equals 0, or 1 this direction, to the left of 0. And less, if the distance is less than 1, it can be anywhere in between. And that shows us how we can rewrite the inequality as negative 1 is less than or equal to, this is what's called a compound inequality. What's inside the absolute value, x minus 2, and that's less than or equal to 1. In other words, x minus 2 has to be between negative 1 and 1. And notice when you rewrite it, the absolute value signs drop off. So what we're saying is that has to be between those two numbers. And then you just solve it for x by adding the 2, getting x by itself. And since there's 3 parts to a compound inequality, you have to add 2 to all 3 parts to balance that out. So then that would give you negative 1 plus 2 is 1, less than or equal to negative 2 and 2 cancel out, x, which is less than or equal to 1 plus 2. And then we can graph our final solution on the number line here. So this is our initial graph here. So we can say it goes between 1 and 3. 1 right there. And 3 right there. And then it's got closed circles because it can equal 1 or 3, and then it's shaded with the x between those two. So there's the solution right here to the inequality, and then there's the graph right there. Now notice on the next example problem, the absolute value is not isolated because it's divided by 3. So the reverse of divided by 3, to get rid of that, is to multiply by 3. But to balance it out, you have to multiply both sides of the inequality by 3. So that will give us the absolute value of x, because the 3 divided by 3 is 1, is less than 6. So now the distance away from 0 has to be less than 6. So you go up to 6 to the right of 0. And notice this time it can't equal 6. So we're going to put an open circle there instead of a closed circle. And then 6 to the left of 0, again, it could be 6 less than 6 away, so we'll put an open circle right there instead of closed circle. And again, the distance away from 0 is less than 6, so it's all the numbers in between here. The distance away from 0 that are less than 6. So shaded. And then the way you rewrite that, again, when it's between two numbers, you write it as a compound inequality. So you write negative 6. Go from low to high, usually it's written from left to right. So it's less than x. Saying x is greater than negative 6. And x is less than 6. In other words, x is between negative 6. And in this case, x is already by itself. That was the only thing inside the absolute value. And we don't have to regraph this again. The graph is still going to be the same as original. case, since we didn't have to isolate the x once we knew it. Okay, let's take a look at a couple more examples here. On this one, the absolute value is already by itself. So first thing we do on our graph here, the distance away from 0, notice this time it's greater than or equal to 3. So now here's where it's equal to 3 away from 0, or equal to 3 away from 0 this direction, the distance from 0. But now the distance has to be greater than or equal to 3, so it can't be in here, that would be less than 3 away from 0. So now it's off either this side, the distance away from 0 is greater than 3, or this side, the distance away from 0 is greater than 3. And since it's not in between two numbers, it's either this way or this way. This one we can't write as a compound inequality, we have to write as two separate inequalities, because it can go this way or it can go this way. It can't be both, on my favorite. That's again because the distance is greater than a number rather than less than a number. So this x plus 1, we look over here, is less than, notice it's the same direction as your arrow's pointing, that's where our less than and greater than signs come from, or equal to, because it can't equal 3, negative 3. Or the other possibility is that what's inside the absolute value, x plus 1, could be greater than or equal to, again, 3. So those are two possible places of x to be. And then you just solve for x by isolate it. In this case, just subtract the 1. And this one, if this x is less than or equal to negative 3 minus 1, it's negative 4. Or x is greater than or equal to 3 minus 1. So that's our solution. And then to graph it on the number line, say we start with the negative 4 here. So negative 4 is right there. It can equal negative 4, so we close circle there. And it has to be less than or equal to negative 4, so heading this way. Notice again, same way, it's pointing the same way as our inequality sign. Or the other possibility is greater than or equal to 2. So if it's equal to, that's equal to, or greater than, if it's greater than or equal to 2, or to the right of 2. So once again, the arrow's pointing in the same direction as inequality sign. Without getting a graph of our solution. So this first graph is to help us rewrite it here. And then the second graph is our final solution. Let's look at one more example. On this one, the absolute value is not isolated yet. So we first have to divide by the number on the outside negative 2. Be careful, you can't just distribute it into an absolute value. That will change the answer oftentimes. So you have to isolate the absolute value first, which gives us absolute value of 2x minus 1. Remember, when you divide or multiply an inequality by a negative number, you have to flip the sign. So now it's switches from less than to greater than. Negative 4 divided by negative 2 is positive 2. So distance away from 0 this time is greater than 2, so it can be 2 this direction, but not equal to 2, so it's a circle, or 2 this direction, but not equal to 2. And the distance is greater than 2, so it has to be further away from 0 than 2, so either this way or this way. So now we can rewrite it again, because it's going this way or this way. You have to write as two separate inequalities. So what's inside the absolute value, 2x minus 1, could be less than, this time not or equal to, the open circle, less than negative 2, or the other possibility, it's inside the absolute value, 2x minus 1, could be greater than 5. And then just solve for x by isolating, so just add the 1. And this one would give you 2x less than negative 2 plus 1 negative 1. And on this one you add 1. 2x is greater than 3. And then if you divide by 2, isolate the x. x is, this time we don't flip, we divide by positive, so less than negative 1/2. Or the other possibility is x is greater than 3/2. So on our graph, on our number line here, so that's our solution. On the graph on the number line, at negative 1/2. Well, negative 1/2 is between negative 1 and 0. And we put an open circle. And x is less than negative 1/2, so the number is less than negative 1/2, there's one left of it. Don't worry about how long your arrows are, as long as it's going in the right direction. Because it keeps on going further. And then x is greater than 3/2. So 3/2 is the same, you're at a fixed number as 1.5. So 1.5 right here, between 1 and 2. And x will be greater than 1.5 or 3/2, so you shade to the right. And there's the graph of our solution. And that concludes the notes on the topic of solving absolute value inequalities.